Chapter 3 Oxidation Reduction Potential Exercise 2 Silver Aluminium Cell. A galvanic cell is constructed using the following two half cells. The aluminum half cell, an aluminum strip of mass M1 equal 10 gram, is dipped in a beaker containing 100 milliliter of an aluminum chloride solution in which concentration of Al3 plus ion equal to 1 mole per liter. We write the given. We have Al half cell, the mass of Al strip M1 equal 10 gram, the concentration of Al3 plus ion equal 1 mole per liter, and the volume equal 100 milliliter. The second half cell is the silver half cell. The given of this half cell. The silver half cell is formed of a strip of mass M2 equal 10 gram dipped in a beaker containing 100 milliliter of silver nitrate solution of concentration of Ag plus ion equal to 1 mole per liter. Then M2 of silver strip equal 10 gram, concentration of Ag plus ion equal to 1 mole per liter, and the volume of solution equal 100 milliliters. The two half cells are connected using a salt bridge containing jellified solution of sodium nitrate Na plus NO3 minus. The schema of the constructed cell is given in document 1. In this schema, we observe that the direction of the electric current I from silver strip to Al strip. And we know in a galvanic cell that the direction of electric current from the cathode to the anode, then the silver strip is the cathode and Al is the anode. By referring to document 1, show that Ag strip is the cathode of the cell. This is what we have said. Then we say part 1.1 that in a galvanic cell, the direction of the electric current I from cathode to anode. In this cell, the direction of I is from Ag strip to Al strip. Then we deduce that Ag is the cathode and therefore Al is the anode. 1.2, write the equation of the half reaction taking place at each electrode, at anode and at cathode. Then deduce the equation of the overall reaction of the cell. At anode, that means Al half cell, at anode oxidation takes place. In oxidation, the atoms are transformed into corresponding cations. Al is transformed into Al3 plus 3 electron. Oxidation half reaction. At cathode, reduction takes place. That means cations, Ag plus, gains electrons, 1 electron, to become Ag atom, which is reduction half reaction. Now the overall cell reaction. To write the overall, we must have same number of exchanged electrons in the oxidation half reaction and in the reduction half reaction. In oxidation, you have 3 electrons, loss of 3 electrons. In reduction half reaction, you have gain of 1 electron. Then we multiply the reduction half reaction by 3. Then the first reaction remains the same. Al give Al3 plus 3 electron. The second half reaction become Ag plus 3 Ag plus 3 electron give 3 Ag. We multiply it by 3. Now the overall reaction, we simplify 3 electron and 3 electrons. The overall reaction becomes Al plus 3 Ag plus give Al3 plus 3 Ag. This is the overall cell reaction. 1.3, write the cell notation. In cell notation, we start with the anode, which is the negative pole. At anode, Al atoms are transformed into Al3 plus ions. The salt bridge separates the anodic half cell from the cathodic half cell. We represent the salt bridge by 2 parallel lines. At cathode, in the cathodic half cell, Ag plus ions are transformed into Ag, which is the positive pole. This is the cell notation. 1.4. Answer by true or false justified. The concentration of Al3 plus ions decreases with time. What happened in the Al half cell? In the Al half cell, Al atoms are oxidized into Al3 plus ions. Then we have formation of Al3 plus. Therefore, the concentration of Al3 plus will increase. Therefore, the statement is false. 1 false, because in Al half cell, Al atoms are oxidized into Al3 plus ions. Then the concentration of Al3 plus ions will increase. 1.4.2. The reaction of the cell is complete. To identify whether the reaction is complete or not, we should calculate the variation in the reduction potential, delta E. Delta E equal E of the couple at cathode, which is Ag plus Ag, minus E of the couple at anode, which is Al3 plus Al. In the given, E of Ag plus Ag equals 0.8 and E of Al3 plus Al equal minus 1.66. Then delta E equal 0.8 minus 1.66 equal 2.46 volt, which is bigger than 0.30 volt, then the reaction is complete. If delta E bigger than 0.30 volt, then the reaction is complete. Now, 1.5. Sodium ions Na+ migrate from salt bridge toward the cathodic half cell. Explain this statement. What will happen in the cathodic half cell, which is Ag half cell? In the Ag half cell, Ag+ ions are reduced into Ag. Then the concentration of Ag+ ions decreases. That means the sum of positive charge decreases. To keep the charge balance in the solution, the positive ions in the salt bridge move toward the cathodic half cell, which is Ag half cell. Then 1.5 in Ag half cell, Ag+ ions are reduced into Ag atoms. Then the concentration of Ag+ ions decrease. Therefore, the sum of positive charge decrease, while sum of negative charge from NOT- ions remains the same, since NOT- ions remains the same, did not undergo any transformation. Then we have decrease in the positive charge. To keep the charge balance in the solution of Ag half cell, Na+ ions, cations in the salt bridge move toward or migrate toward the Ag half cell. Part 2, quantitative study of the cell. After 1 hour, 3,600 seconds of functioning of the cell, the mass of aluminum strip becomes 9.9 grams. The initial mass of aluminum strip was 10 grams. After 1 hour, it becomes 9.9 grams. It decreases. Calculate the variation in mass of aluminum, then deduce the variation in the number of moles of aluminum after 1 hour of functioning of the cell. 2.1. The mass reacted of aluminum equal initial mass minus mass left after 1 hour. Initial mass of Al equal 10 grams. The mass left equal 9.9. Then the mass reacted equal 0.1 gram. 0.1 gram. Now the number of mole of aluminum reacted equal mass reacted over molar mass equal 0.1 over molar mass of aluminum is given equal 27 gram per mole. Then number of mole of Al reacted equal to 3.7 10 to the power minus 3 mole. 2.2. Determine the concentration of silver ions Ag+ after 1 hour of functioning of the cell. The concentration of Ag plus ions decreases since Ag plus ions are transformed into Ag. First, we should calculate the initial number of mole of Ag plus, then the number of mole of Ag plus reacted. We deduce the number of mole of Ag plus left, and then we calculate the concentration of Ag plus left. And we start with N0 of Ag plus. N0 equal concentration of Ag plus times the volume equal 1 times concentration 1 mole per liter, volume 100 milliliter, that means 0.1 liter equals 0.1 mole. This is the initial number of mole of Ag plus. Now, number of mole of Ag plus reacted. We have calculated the number of mole of Al reacted. From this number of mole, we can deduce number of mole of Ag plus reacted according to the stoichiometry of the overall cell reaction. 1 mole of Al reacted, 3 mole of Ag plus are reacted. Then, according to SR, of the overall reaction, we have number of mole of Ag plus reacted over 3 equal number of mole of Al reacted over 1. Then number of mole of Ag plus reacted equal 3 NaL reacted equal 3 times 3.710 negative 3. This is the number of mole of Al reacted equal 11.1 10 negative 3 mole. This is the number of mole of Al reacted. Now, number of mole of Ag plus left equal N0 initial number of mole of Ag plus minus number of mole of Ag plus reacted equal 0.1 minus 11.110 to the power minus 3 equal 0.0889 mole. This is the number of mole of Ag plus left. Finally, concentration of Ag plus left equal number of mole of Ag plus left over the volume. Number of mole equals 0.0889. The volume equal 100 milliliter, that means 0.1 liter equals 0.889 mole per liter. This is the concentration of Ag plus left. 2, 3. Based on the variation in number of moles of Al, calculate the number of moles of electrons exchanged after 1 hour of functioning of the cell. According to the half reaction, Al give Al3 plus 3 electrons. 1 mole of Al gives 3 mole of electrons. Then number of mole of exchanged electrons over 3 equal number of mole of Al reacted over 1. Therefore, number of mole of electrons equals 3 number of mole of Al reacted equals 3 times number of mole of Al reacted equal to 3.7 10 negative 3. Then 3 times 3.7 10 negative 3 equal 11.1 10 negative 3 mole. This is the number of mole of electrons exchanged, 2.3.1. Now 2.3.2. Deduce the number of electrons N exchanged after 1 hour of functioning of the cell. From the number of mole of electrons equal N over Na, we can deduce the number of electrons N equal number of mole of electrons times Na. Number of mole of electron 11.1 10 negative 3. Number of mole, Avogadro's number Na equal 6 10 to the power 23 equals 66.6 10 power 20 electrons. This is the number of exchanged electrons during 1 hour. 2, 3, 3. Calculate the quantity of charge Q produced after 1 hour of functioning of the cell. Quantity of charge Q equal to number of electrons times the elemental charge of 1 electron E. Number of electrons 66.6 times 10 to the power 20 times elemental charge is given equal to 1.6 times 10 to the power minus 19 equal 1065.6 Coulomb. 2.3.4. Finally, deduce the intensity of the current I delivered by the cell after 1 hour. Q, quantity of charge equal I times time t. Then I equal Q over t. Q equal 1065.6. Time 1 hour, but it must be in second, equals 3600 seconds, equal 0.296 ampere. This is the solution of exercise 2.